Okay, let's go step by step. If everyone can try to access the file, let's go to open file. And there should be a file called competing risk model. You guys find it, or you guys have the risk final data, whichever one. Yeah. So inside the competing risk model, you should find the R Shiny called competing risk R Shiny model. So if you open that, and you should see the file there, and you can reload it or run the app. It should take you to the file where you can browse the data. There. What's that? Oh, okay. I'll just wait for everyone to first run the file. Oh, that's okay. She mentioned something about the external one. The data set is the BMT one. Yeah, I'm just going to show you. So when you browse, you should go into that and you will see a file called BMT. What's that? Internet is getting. What is connected? Oh, it's connected. The BMT? Yeah, yeah, yeah. No, this is the different. Did you get BMT? Oh, was it shared? The new one that Dr. So Dr. Jaisil, I think that's a old data. The new one, is it shared with everyone? Yeah, this is, yeah. Do you guys have a folder called, so there is two folders for competing. If you look at my screen, there is competing risk model folder, and there is another folder called competing risk final data underscore 14 December. Oh, the 14 December is not there with you. So, yeah, I think you guys have this one, I believe. Yeah, if you can open the competing risk final data, in that there should be a. No, you can open BMT there. In that one, you should open the BMT one. Oh, can you go out of one step above? No. Oh. Yes. Yeah. Oh no, this one was shared this morning. That's okay. Got that one? Okay. So in that time variable would be at the end called as combined underscore time. And then the status variable would be the combined outcome. So if you, I'll show you in a second, you can look at it in the data preview. The combined outcome will have three status in it: 0, 1, and 2. It's not 0 and 1, just like how you have ran before for Kaplan-Meier or the Cox proportional model. For competing, there'll be three status. So for the 100 patients that we have randomized in this trial, each one will carry one status, either 0, 1, or 2. 0 is no event, which is censoring. 1 is an event, and 2 is a competing event. So they can carry either one of those event in it, right? So that's why we need to set up the data like that to run a competing model. And then covariate would be the TX is a treatment group. Then if you can run it. Group variable is optional if you want, but it's not required at this point. The covariate would be TX, which is the treatment group. Yes, everything should be there. I don't know if she can, did you touch base about the final grade? No. So let's first look at the cumulative incidence plot. And this is a Alan Johansson estimator. And you can see here, blue line is the event 1, which is the event of our interest. And the event 2 is the competing event. And you can see there is less truncation and less censoring, and this is happening because there will be less number of patients on the competing events at this point. And now you can also, now we have two different ways to calculate the competing event. Shikan, would you like to quickly touch base about what's finite grade if you want? But the first one is here did the cost specific. Finite grade some distribution. it's a lot of under controversy right now.
That's what I was just going to guess. It's come under criticism. The assumptions of climate variance are
Is
not really satisfied.
yes. So that's another reason why we are not primarily advertising that right now. It is under a lot of scrutiny, but anything with competing risk right now, we are using the cost specific hazard model. And as Shrikant was mentioning, it will spit out the hazard ratio for both the cost one and the competing one. But the interest of hazard ratio is only on the first event, that is event one, which is cost one. And you can see here, it's not significant because it includes one, it has a lower bound, an upper bound, and the hazard ratio is 1.479. I think, except, I think she's just downloading the data, but pretty much everyone they're able to. Yeah, yes, yes.
Yeah, correct. Yeah.
The new one is working.
Yeah.
GMP.xml.
Yeah,
Yeah.
yesterday evening we corrected it.
And then it will also give you the fine and gray. But again, right now we can skip that one. Let's see what the research takes us to. Any questions on this one? Yeah. This one? So the combined time is a survival time. So right now it's named as combined time, but it's a survival time of a patient, whether including the death as a censoring and whatever you need to take. Outcome is the status where the patient is either 0, 1, or 2. 0 is censoring, and 1 is an event of your interest, and 2 is a competing event. And then group variable is optional at this point, and covariates of the model is the treatment group that we are testing against. How is treatment A compared to the treatment B? It's simple as 3 covariates.
The message is that when you have a competing event, you should not do Kaplan-Meier analysis.
Yeah.
You should ideally do this. You can put as a covariate if you want.
Not as a plot. At a plot level. So actually, I'll show you something. I saw something, but if I'm right, this is what.
If you put a treatment, then there will be 4 graphs, 4 lines.
I think we can do that. We need to refine it because now it's a dotted line at this point. Maybe the color coded would give you more information there. But yeah, that's why the group variable is over there. So I put the same TX in the group, and now I'm getting 4 lines, which is comparing the 2 groups plus for the competing 2 groups.
So that is a big question. You are saying competing risk is there or not?
Taking into consideration of competing risk is clinical endpoint, right? Like it's when you run a trial, it's competing. Death is in most of the cases competing. Let's say you include death as your primary outcome, then of course then nothing else is your competing at this point. But a lot of times we use a CV death as your competing, then non-CV death would become your competing. It's better to adjust for competing in a clinical trial because the journals are nowadays asking for it. We are not seeing a huge difference in results, whether it's competing or non-competing. Most of the time, the results are pretty much very identical in our large trials that I'm talking about. So, multi-state
is different.
Multi-state is a whole different one. I don't think it's a direct comparison of that one. Right now, we can compare with the competing with the Cox model, but multi-state model is a different one. It is all about the recurrent events and multiple events. So, yeah. Right now, there is no comparison.
But definitely, there will be a difference in Kaplan-Meier estimates. We should not do that. And Cox will be different as compared to cost-specific hazard model. Yes.
Sorry, which one?
Upper part of the graph are the two events.
I'm not entirely sure whether we can directly use like that because my labeling, I mean, the labeling looks different. We need to work with him to fix those things.
No, the first one has event one, event two.
Yes,
When we,
Cause one, cause two.
event one is the,
but in the groups, what happened to the causes? Like in the bottom one?
no, I think the, no, I think the labeling, I think the labeling was, yes, we need to interpret only the cumulative, just like Kaplan-Meier, when you are looking at it, it's very similar concept of looking at the Kaplan-Meier. And all we are looking at is only the blue line. Since you have asked for whether we can see by treatment, I tried to put this in the group, but I think the labeling need to be fixed.
No. This is a one variable type of.
No, but I didn't put that variable.
Yeah, bone
That
marrow.
variable
and
is also TX.
There are different type of one. Yeah, we have given what is it, BM and PB and all that. So this is. So the labeling is that she asked the question. You asked the question about where is that type or the. Just go to the first one. Yeah, event one and event two. So if you take event one by BM, event one by PB, 2 curves. Event two, 4 curves. Labeling is not very
I
clear.
think it's only the labeling issue. So for example, if you look at this one, the bottom, this line should be the event one for one treatment group. And
Based on
most
P-
likely this one would be the second treatment group and then the competing death. So there is 4 lines.
It's subdivided, the top graph subdivided into two.
2.
So,
Yes,
yes,
correct.
the top graph is subdivided into 2. Yeah. But the coloring and the labeling is pretty much confusing. Good question. Good question.
No, event one is the competing event.
What is a
Oh,
competing
how
event?
did you choose that one?
No, that's the competing event. The top blue line is the
Here?
second event, the red is the competing event.
Yes. So your data set need to be in 3, it has to have 3 status, 0, 1, and 2. You got it?
Event one is blue, event two is red.
Yes. Even 2 is a competing.
No, question, what is the event? What is?
Event is
Oh, what is the event is,
the outcome.
I
Event is the
can,
outcome.
no, if,
What is that outcome?
oh, what is the outcome could be, I don't know.
No. Competing event means the second event is trying to kill the patient. When you have a specific question, that is the first event. So second event is what?
Second event is a competing event.
Yeah. What are they? Ah. So then the relapse is the second event. Death is the first event.
There's only one competing event. There's only one competing event.
Yeah. Now I remember this is a relapse. Yeah. Competing event. That is event 2. Yeah, that is what he is saying. No.
So in the Word document,
The code is given.
so
Just,
the Word document,
Yeah.
Kumar, can you
What does
please
it
show
say?
the
it
code?
says time to relapse, time to chronic GVHD, time to death.
Time to relapse and time to
relapse,
death.
time to GVHD, and time to death are the three.
3.
But they don't say which is event 1, 2.
There's a one event, GVHT was excluded because of the small events. So they were dealing with the relapse and death. 2 events.
Line is death and the red line is relapse.
Correct.
Or the other way around.
Yeah, correct. No.
Relapse must be the blue line.
Blue line. No. The competing area is always a smaller one. So it is adjusted for, always death is a higher probability.
So death is blue and the competing.
So
event
for
is
this study, death is the event 1 and the blue,
Yes.
red is competing event, which is the relapse.
So can you please go to the code, the
Yep.
document, Word document,
the graph below is divided the same
Yeah.
thing by
the combined event. There's one.
I'm not able to find that one.
Oh, okay.
It's only in the data. I don't see it here.
Yeah, here. Combined event. You showed some
We
time
don't-
back, combined event. Data.
Yeah. So, yeah, you can. So think of this one, like
Please go-
any event for that matter, like let's say maze is your event and death is your competing event. All you need to code is 0 would be no event, 1 is your maze, 2 would be your competing event, death. 0, 1, 2 category should be there. And then your survival time remains the same. You calculate the total survival time and then you just plug in.
this is the usual Kaplan where now we have a category.
Category 2, yes.
Yeah,
Yes.
correct.
And we have an inbuilt system and models that will take care of the competing one. And it gives you the similar results again. Great.